Hi everybody, I'm Naveen Vinayagamurthy, and the title for my project is Analysis of Trending YouTube Videos. So as the title says, I wanted to analyze uh, videos that have trended on YouTube over the past year. So I basically wanted to see like what metrics should a certain video get through in order for it to start trending in the trending page. So the data for data I collected it from the following Kaggle website. This website had this website had trending video data sets for YouTube for different countries and for different years. I specifically filtered out data for 2023 and US YouTube data. So initially, the dataset had 72,382 rows, and after pre-processing and filtering out only for the year 2023, we were left with 9,981 rows. So in the early stages of this project, we were instructed to do a lot of data analysis and data visualizations. So these were some fun questions I took upon and I answered by doing those analysis. So let's see one by one. So the first one is, oh, sorry. So the first one is which month was more beneficial for the creators. So as we can see, January gained the most views. Videos posted in January had gained the most views, followed by April and September. One interesting thing to note is, if you see for January, we can see the count of videos posted is also more. So that kind of nullifies that spike in views. But for September, we can see that the count of videos is over here in middle of the bunch, but the views gained is exponentially more. So September is a very beneficial month for YouTubers by this. Yeah. The next one is which day of the week a video performs better. So basically, what this says is that which day, if you post a video, that video will trend better. So we can see that average views is high on Saturday and Friday. Um, and interestingly, the count of videos posted in Saturday is also very less. So the chance of it for trending on Saturday is really high going by this data. Yep, this is the answer. The next one is which hour of the day should a creator post for the video to go viral? As we can see, uh, from 3 p.m. to 5 p.m. is the prime time for the video to be posted. These videos uh, gain too many attraction as it is like closer to dinner time, like evening dinner time, and kids would return from their schools and they tune in to watch these videos. So there's going to be a spike during the later stages of the day, obviously. That's why when a creator posts from 3 p.m. to 5 p.m., you can see the total the total views gained is too high. And we can see a trend here. So basically, afternoon hours are the most crucial ones going by this plot. And the morning time when you post a video is when obviously no one's going to watch. They'll be at work and they will be at school and all those. So that's why it's always better to go for posting a video in the afternoon. So the next is what is the average title length, the title size for a trending video? So, as you know, all of the data in this, all of the records in this data set are of trending videos. And we can see that most of the trending videos have this word count to be 7, followed by 8, and followed by 6. The next one is which category of videos trend the most? So for this, YouTube has in total like 29 categories. I filtered out the top 15, I think. Yeah, I think it's the top 15. And as you can see, there's a huge skew towards gaming, entertainment, sports, and music. And yeah, so if a creator aims to post a video on these four categories, you can expect their videos to trend more. Now let's talk about some technical insights that we found from running various models. So in this project, we were obviously instructed to every 3 weeks, we were given time to implement many models. So we'll be looking these models one by one and see what insights we could extract from these models. So the first one is the recently implemented one, multinomial naive Bayes. Um, so for this, how to say this? Um, so for this, I set this to be a classification task, and this task was to classify a video based on title, classify a video's category based on the title. So we saw earlier that gaming, entertainment, and sports were the three most dominant video categories that were trending. So I considered only the records for these three categories, and then I pre-processed the title of the video for each of these records, and then we trained a multinomial model to classify these categories. And the model performance was good with an accuracy of 0.84. And this is the confusion matrix that we obtained. We can see that the model has performed really well, going by the less number of false values compared to the overwhelming high count of true values. So the next model that we are going to talk about is decision trees. So with decision trees, again I set it out to be a classification task where I wanted the model to predict how long a video trended based on its increase in likes and increase in comments and increase in views. So basically, in the initial data set, I said I had like 71,000 rows, right? So not only by filtering 2023's records, I got it down to 9,981, but I also had to merge the data, like the rows, because many videos were like repeating as many videos trended for more than a week. So it kept repeating in the data set. So I had to left join these records. So after left joining these records, I got the rows count to be 9,981. So by doing this, I got the initial start date of its trending and the final day of its trending. So with this, we can like compare, no, we can calculate the percentage of like increase in likes, views, and comments. So that's how I got these three features. And then I could also calculate how long a video trended, like the to exact days how long it trended. And I categorized these values into two. One class was a video trending for a week, and another class for video trending. No, the first class was video trending for less than a week, and the second class was video trending for a week or more than a week. So I segregated the classes and then I trained a decision tree model. Initially, I trained this model with without setting any limits for the branch. And then I tested out cost complexity pruning to provide an optimal decision tree. Cost complexity pruning is nothing but testing out different values of CCP alpha. This is a hyperparameter in the model. So you test out these different CCP values and you record their test accuracies. And at one point, the test accuracy would start be there, like there would be no change in the test accuracy. So when it hits a point where there is no change, we can take that CCP alpha's value to be the ideal one and then give it to the model. And then this is the finalized decision tree that I got. Now let's talk about unsupervised classifications. So over here, we were instructed to implement two methods, K, K-means classification and hierarchical classification. Oh, I'm sorry. K-means clustering and hierarchical clustering. Both these techniques almost resulted in the same classifications. We can see I have specified like what ranges the data points were classified to. Like for cluster one, the data points had views ranging from 155K to 4.3 million and engagement rate of 0.0 to 0.07. For cluster one, we had views ranging from 22K to 2.1K. 2.1 million and engagement rate of 0.05 to 0.26. And for cluster 2, we had data points ranging from 35K to 1.5 mil and engagement rate ranging from from 0 to 0.05. And this is the plot that we got after running the model. As you can see, this is a very ideal split, I would say. And the number of clusters, I forgot to mention, this was determined by silhouette method. So the final model that we implemented, the final technique that we implemented was association rule mining. So for this, we took uh, we took the data only for gaming, and we wanted to see which words repeated the most in the description of each of its videos. And I modified the descriptions a bit. So if a description contained words from the title of the video, I would give that word a title word. And if it had words from tag, I would give it tag word. And if it contained any URL, I would give it URL. So like this, I pre-processed and edited the description of these videos. And as you can see, these are the words frequencies. You can see that URL is the mostly repeated one, followed by title word, tag word. URL makes sense because in the gaming space, people would always recommend others to go follow their socials and buy their merchandise. So this is why URL has these many occurrences. And here are the rules that we obtained by confidence and by support. So by confidence, we can see that Twitter is always associated with URL in almost all the rules. So how to interpret these rules? So for the first rule, we can say that when we have Twitter in most of the in 98% of the descriptions, when we have Twitter, we can expect URL. So for second, we can say that in 98% of the uh, descriptions of the videos, when we have tag word and Twitter, we can expect URL. So that's how we interpret this. And that's it from my side. Um, Thanks for putting up with me and my rambling. Have a nice summer vacation. Oops. Ah, crap.